Remember that we have learned 3 different forms of quadratic equation. Now, let's see how these quadratic forms are related to how the graph looks like. Starting with the standard form, y equal to x squared minus 2x minus 3, this form makes the y-intercept clear. It's the constant term c, which is minus 3. Look at the graph. The parabola crossed the y-axis at exactly 0, minus 3. You can read this directly from the equation without having to do any calculation. The same equation can also be written as y equal to x plus 1 multiplied by x minus 3. In this case, this form reveals the x-intercept instantly. When y equal to 0, we get x plus 1 multiplied by x minus 3 equal to 0, so x equal to minus 1 or x equal to 3. Look at the graph. The parabola crossed the x-axis as exactly minus 1, 0, and 3, 0. The vector form tells you where the roots are simply by inspection. And lastly, we have the vector form where y equal to x minus 1, you square this whole thing at minus 4. This form shows the vertex directly. The value h equal to 1 and k equal to minus 4 give us the vertex at 1, minus 4, and x equal to 1 is our axis of symmetry. On the graph, you can see the parabola lowest point is exactly at 1, minus 4, with the perfect symmetry around the vertical line at x equal to 1. What's really interesting here is that all 3 forms describe exactly the same parabola. The graph doesn't change, only what information from each form is highlighted. The standard form shows us the y-intercept, the vector form reveals the x-intercept, and the vertex form shows us where's the turning point in the graph. This is why understanding different forms is useful. Depending on what information you need, whether it is intercept, vertex, or other features, you can choose the form that makes the information most visible.